Hello and welcome to this presentation on building your own spatially enabled web app with modern frameworks and tooling. My name is Cameron Smith and my co-presenter today is Ryan Libid. We're both developers on the Configurable Apps team here at Esri, and today we'll be talking about some of the libraries and resources that we use to create our apps. We'll also be discussing how to combine these resources with two popular JavaScript frameworks, React and Angular. And at the end of the presentation, we'll have links to React and Angular starter code repos that already have our libraries and resources set up so that you can start developing with these libraries and resources too. Our setup includes three main libraries. The application base, which handles common JavaScript API tasks and provides a platform for configurability. The 4x JavaScript API as ES modules, and the Esri Design System, which is a suite of reusable, lightweight, and accessible web components. We'll now talk about the application base. As mentioned, application base handles common JavaScript API tasks for you. It does this by using configuration values that you set up in a JSON file, and depending on the values you set, it can set up OAuth login, fetch metadata on apps, web apps, or web scenes, set the locale for language translation, properly set values on the Esri configs such as portal URL and proxy URL, and also set arbitrary configuration properties in the app. So this library is an open source library, so we can take a look at the repo on GitHub, and we'll see there is documentation on what config properties you can set in the JSON files. And you'll also see that when constructing this application base, you import a class and then you pass in the two JSON file configurations. And those are both detailed right here. And as an example for what you can do with these, if you set up the portal URL and the OAuth app ID for the application that you're working on, you automatically get the OAuth login, so it sets up all of the calls to the JS API that you normally need to make to cause the OAuth login to appear. It sets all that up for you, so that this is an example of a convenience that this library does provide for you. So now I'm going to pass the presentation on to Ryan to further explain the other resources.
Thanks, Cam. Now let's talk about how to import the 4x ArcGIS API for JavaScript as ES modules, also known as ESM. Prior to the 4.18 release, the JS API has shipped as asynchronous module definition, or AMD modules. And when implementing the API as AMD modules, we've also needed to use the require method and a third-party script loader such as Dojo. So since 4.18, the JS API team has put in a lot of work in making the API available as ES modules. So ES modules is now an official standard format on developing and packaging reusable JavaScript code. So a couple things to note. The ESM version of the JS API is currently in beta, and ESM does not require a separate script loader. You can easily install the JS API as ES modules through npm by running npm install at arcgis/core in your terminal. And another important thing is that the functionality between the AMD modules and ES modules is exactly the same. For more info, visit the link at the bottom of the slide, which provides more information on how to get started. Now let's talk about the UI web components from Esri's Design System framework. There's been a ton of effort in creating a new modern design system in the form of web components for the purpose of applying consistent UI patterns across Esri's web products. In reference to the Mozilla Developer Network, or MDN, web components are a suite of different technologies allowing you to create reusable custom elements with their functionality encapsulated away from the rest of your code and utilize them in your web apps. For more info on web components, visit this MDN link. The plan is to drive consistent UI patterns across the platform by using these web components. The use of these components can standardize things like the user experience and accessibility. A couple examples of these components are modals, tooltips, poppers, steppers, and much, much more. To view and interact with some live examples, feel free to visit the page posted on the slide. I also wanted to mention that the component library is open source. The link to the GitHub repo is at the bottom of the slide. In the upcoming demos, we will be implementing the application-based class, the ArcGIS JS API as ES modules, and the UI web components from Esri's Design System framework. Now that we've discussed the libraries and tools that we use in our web apps, let's now jump into a couple demos. In the first demo, I'll show you how to use them in React by building a simple web app. And Cam will then take over and show you something similar, but with Angular. Now let's build a React web map application. Using the Create React App CLI, let's create our app. I'll be naming this project Esri TS Demo. And to set up our React app with TypeScript, I'll be adding TypeScript at the end of this command. After the project setup, let's install some typings for React, React DOM, and Jest. Now that our project has been set up, let's change directories here and open the project in our IDE. Today I'll be using VS Code. Feel free to use any IDE that you prefer. Let's see what our app looks like in the web browser. In the terminal, run npm start to host the app locally and navigate to localhost 3000 in your web browser. If your app looks like this, then you're on the right track. I'll be setting strict null checks and no implicit any to false here for demo purposes. This is just to avoid TypeScript errors throughout the demo. In the project structure, we have the public directory, which is where you can place things like images or language translation files. In the source folder, I've added the application base. Here's the app.tsx file, and the index.tsx file, which is the entry point. In the terminal, let's install React Redux and Redux so we can implement a state management system. Once the installation is complete, let's jump into the index.tsx file and make some imports. To resolve the React Redux error, we'll need to install the typings. Now let's create a Redux folder and a reducers file. So now this reducers file is going to have a function. Let's name that function reducers, and we're going to go ahead and export this function here. Now this reducers function is going to be used for updating the state in the global store whenever an action has been called. So in this reducer function here, we're going to have a switch statement. And in the switch statement, we'll be comparing the value of action.type with these cases here. So a case of set title will be returning an object, and within that object, we'll be returning the spread of the state and the part of the state that needs to be updated. If the cases don't match, we'll just return the state as is. So now that we have our reducer set up and our imports ready, let's go ahead and create the global store. So I'll be creating an init function, and this init function is going to call itself. And I'm going to go ahead and place this React DOM.render call inside of the init function. Now I'll be creating the store, setting that to a const. And when creating the store, I'll be passing in a couple things. I'll be passing in the reducers and an empty object. So now that the store is created, let's go ahead and bring in the provider here. So I'll be adding in the provider component. I'll be setting its store attribute, and the value of the store attribute will be the store that we've created. And within the provider, we will nest the app component. So now the application will have access to the global store. Next step is to import the application base. And at the bottom, I'll have a function create application base, which will return an instantiation of the app base class. In the app base class, we'll need to pass in a config. And in the config, we'll be passing in a config property and a settings property. Config will be application JSON, and settings will be application base JSON. So now at the top, I'll import the JSON files. In the init function, let's create the application base. And once that's called, we'll need to call load. And since that returns a promise, we'll need to add the async keyword here so we can use await. To resolve these two errors, we'll need to create the application JSON and application base JSON files. So in the source, I'll be adding in a config folder. In the config folder, I'll be adding in the application JSON and the application base JSON. In these two files, I'll be copying and pasting the objects, and you can get both of these objects directly from the repo. And once we have the file set up, we'll be adding a base property to the global store and a config property in the global store. Next, let's get the web component set up from Esri's Design System framework. I'll be installing an npm package here. So after installation in the package.json, you'll need to add a node script here. This node script is basically just copying the icons into the assets folder. So in public, I'll just add assets. And be sure to rebuild your project so you can test it out. The next step in getting the UI component set up is to create a declarations file, which will have the typings. So these typings can be found in the project repo. I'll just be copying and pasting these here. Now in the index.tsx file, I'll be importing the styles, the UI components themselves, and a couple methods here. In the init function, I'll be calling apply polyfills. This returns a promise, so I'll need to use the await keyword and define custom elements to define the components in the project. Finally, let's create our first React component. We'll be adding a components folder. We'll then be adding in a modal.tsx file. And in that file, let's import React. I'll also be importing component here. So this will just be a class extending component. And this requires a render method, so we'll just return a div with some text. And we'll need to export this at the bottom. In the app.tsx file, we can remove some of the extra code. We can now nest our modal component and import that at the top. Now if we preview this in the browser, just hit the refresh and we should see some text here. Now that we verified that our modal component is rendering, now let's modify the markup to render out a component. We'll be using the modal component from the components library. And if we preview that, it looks like it's being rendered correctly. I've made some component updates. So in the components folder, I've added a header. And in the modal component, I've initialized state. And in state, I have an open property, which will determine if the model is opened or closed. I've added an onClick, which will close the modal by setting the open property in the state to false. In this header component, I'll be importing some styles here. I also have an object, which will contain CSS class names. And in the component, I have a render method, which returns a header tag and some hard-coded text. Now let's wire up the global state to this component. First thing is to import connect from React Redux. Next, in the header props interface, we'll be adding the config, which has a type of application config. Now, we'll replace the hard-coded text with this.props.config.title. And to get the global state wired up in this component, we'll have a function map state to props. This will return a state object. And by using connect, we can pass in the map state to props function. Second argument will just be null. And we'll be passing in header to what's returned from that. So if we look at the header in the application, you'll notice that it's empty. But now we can update the title in the application.json. Now if we hit the refresh, we now have that value in the header component. The next step, we will be integrating the 4x ArcGIS API for JavaScript as ES modules. And we'll be doing that by installing the ArcGIS core npm package. Now that we've installed the package, we'll need to have a node script here. And this node script will be copying the assets from the ArcGIS core npm package to our public folder. And we'll be using NCP as a dev dependency to copy over the ArcGIS core assets to our project. So let's read run npm start in the terminal so we can rebuild our project and copy the assets from the core npm package to our public folder. Once the project has been built, we should now have the ArcGIS core assets in our public folder. In the index.tsx file, I've imported the JavaScript API styles. I've also updated the styles in the index.css, as well as the app.css file. Let's add a map to the application by leveraging the functionality from the ArcGIS core ES modules. We'll start by creating a view component. I set up the view file in advanced. At the top, I'm importing items from React, connect, the application base, create map from item, and the map view. I also have some interfaces for the props and the state. I have an object to use for CSS classes. I've also typed a component with the props and state interfaces. And this property here is what we're going to use to pass into the map view container property. And this is just a reference to the div element in the JSX. So when the component is mounted, we'll be calling create view. And on create view, we'll be accessing the portal item, and this will be accessed through the global state. Now we'll be handling any app proxies that's within the portal item. And we'll also get the web map items, and this is accessed through the global state. So after iterating through the web map items, once we get the item, we'll pass that into create map from item. We'll then take the map and pass that into map view. And you'll see that there's also the reference to the map div. Now let's map the state to the props. And let's connect this component to the global state. Now that we have the view component set up, let's add this component to the app.tsx file. And the last thing to do is to test this out. So now it looks like we're getting an error here in the browser. In order to resolve this error, we'll need to go into the config file, go into the application.json and paste in a web map ID. And if we test again, there's the modal component and there's the map. Nice, looks like our app is complete.
I'm now going to go over the Angular portion of this demo. As a reminder, what this is an Angular project set up with all of the resources and libraries that we talked about. And if you visit this link to this GitHub repo, it's going to show you a starter code library that you can access and start with all the libraries and resources set up. And also the demo that we go over is accessible on the demo-final branch of this repo. This is the application that we're going to end up with. It's a map of Texas with blue dots signifying historical marker plaque locations across Texas. We got this data from a website called openplaques.org, which is a crowdsourced website that collects data on historical markers. Right, so we brought that into the map here just for the state of Texas. And what this allows us to do, this application, is say we were driving from Odessa here to Sweetwater. If we click on our beginning location and then click on the end location, it's going to give us our route along a driving route along between these two locations and show us the amount of historical markers that are within our specified buffer amount. So in this case, it's 26 plaques, and you can arrow through them and find if you potentially want to visit any of these locations along the driving route that you're taking. And you can change the buffer value, and that's going to change the amount of plaques that are brought back. We're going to take a look at the code of the application now. We have an Angular project set up here. It was just set up with the Angular CLI. And so if we take a look in the app component, which is our root component of this application, we'll see some use of some calcite components, which actually cause the main structure of this application. So we're using the calcite shell, and I'm going to bring over the documentation that is available for the calcite shell. And what you can see from this is literally it's an entire structure, like format for the basis of your application. and it's really cool. It's responsive out of the box, and has a bunch of different components that we're not even utilizing. We're just utilizing the panel and the header in our application, but this is fully featured and really cool to use. So if we take a look back at our code, we are placing the different parts of it with this slot attribute. So we're placing the shell header in here, and we're placing the side panel right here. And the side panel is another angular component that we have in here. And we're also setting up the map as well. So the cool thing about Calcite components is that you have, just from setting it up in the application, you have access to all of these different components. So you can come in here and see the different components that you have access to, and take a look at there's the HTML of it. You can play with the attributes of it. There's also docs that you can read for all the different things that you can do with it. And we can take a look at the HTML here, copy paste it into our application. And so this is for a modal, and this is going to work right out of the box. And we recompiled, and so now we have access to the modal, and we can set it up any way we want to. All right, so now we're going to take a look at how we accomplish the routing functionality in this app. There is a service called the routing service that we have here, and this is where the primary logic for the routing happens. You're going to notice that at the top we are importing everything that we need from the JavaScript API through this ArcGIS core module, and that's convenient because that was the one that we can just install with npm install. So just doing that, and then we can import things from the JS API, as easy as that. The way that we do the routing is we use this service from the Esri location services called routing, and that is this URL right here, and we pass that to a class from the JS API called the route task, which is going to allow us a good interface to send off these routing requests that we do. So now we're going to go through the code here. So we are in the constructor of this service. We are waiting for the map view and the map to be populated. Once they come through, we're taking a routing layer, which is just a graphics layer, a new graphics layer that we instantiated here. We're taking that and adding that to the map. That's going to be the place where we put our start and end points and the buffered polyline. And we wait for the map view to be initialized, and then we get the config from the application base, and we're going to talk about that a little bit later. But inside this config is an API key, and you do need an API key for the routing service in order to utilize the routing service, and you can get that from your developer account. So after we have that all set up, we set a event listener for a click on the map view, and then once a click happens, we do this process click function. We come down to the process click function, and the way that this works is that we are looking at the graphics on the graphics layer for the routing that we're doing. We're looking for that, and we're looking how many graphics are on that graphics layer. If there's no graphics on the graphics layer, we know that that first point that we're adding should be the start point. If there's already one graphic on the graphics layer, we know that it should be the end point. And so that's how it decides which point to add based on which click. And the add graphic function is just a pretty simple function that defines the symbol of the graphic and adds it to the graphics layer. So after the destination point is added, we call this getRoute function, And we're going to take a look at that. And this is using the route task that we showed up above. And it's passing to the solve function these route parameters. And all that is a class from the JavaScript API that we're passing this, this property to, the stops property. We're just passing in pretty much the start and end point as graphics here. And we're also specifying that it should not return the directions, which is also a possibility for the routing service. It can actually return like driving directions for you, which is pretty cool, but we don't need it for our purposes here. So we pass those route params to the route task and wait for the result. And as a result, we get the route itself. So the polyline that goes from the start point to the end point. We take that and we add that to the graphics layer, the routing graphics layer. And then we call the buffer function. So that's going to do our buffer for us around the polyline. First, we have to make sure it's the right spatial reference to be acceptable to the buffer function. So we have this polyline that's of the right spatial reference. We pass that to the buffer function, and we get back a buffered line. So we end up taking that buffered line and adding. So we define a symbology or symbol for it, and then we take it and add it to the graphics layer, the same as the other ones. And all this is some logic to when we redo the buffer, it just takes out off the buffered polyline. It takes it off and then it puts it back on. So that's that. But then, so at the end here, we've just added this to the graphics layer, and now we're going to do a call to do a spatial query for the historical plaques layer. And with that, we're passing the buffered line and assigning that to the geometry property of the query that we've generated. And then we're passing that to query features on the historical plaques layer. And that is going to return the features that are within the buffered polyline on the historical plaques layer. And that's what we want. So we also, when we get this back, there's no ordering to it, so we have to sort the features along the line. And the way that happens is we pretty much just do a distance sort from the start point to, so the closer a point historical plaque is to the start point, the further up it's going to be in the sort, pretty much. So the things that are farthest away from the start point are going to be farther down. Right, so that's how we accomplish that functionality. Okay, so now we're going to take a quick look at application base. We have another Angular service set up here called application base service, and this handles the instantiation of application base in our application. You can see that we are pulling in from the Angular environment file two properties, application and application base, which are needed in the instantiation here. And we get the results back here and we provide them as behavior subjects on our service, which can be consumed throughout any other component or service within our module. We're going to take a look at the environments file here, and we see all the different configuration parameters that we can put into these two variables. And yeah, so we're going to demonstrate one thing that we can do that enhances the functionality of this application. So in the URL params, here we can add a start point and an end point. And by doing this, adding these to the URL params here, what application base is going to do for us is automatically take these properties from the query string of the URL and put it inside of this config variable that we can use right away without having to do anything else for that. So, so we just did that with start and endpoint. And I'm going to take this function right here and paste it into our routing service. We're back in the routing service. And you'll see up here that we already have access to the config. And what we're going to do is take this handle query params function and call it after we assign the API key up here. Oops. And pass in the config. So what is this doing? So once we wait for the map view to load here, we get the config, and after assigning the API key for the routing functionality, we can handle the query params, and what this does is checks the config for the start point and for the end point, and if both of those exist in the query string, then it calls a process click for both of those to automatically start the routing functionality of this. And so we've got a URL right here. We just allowed our application to recompile. We've got a URL right here with a start point and an end point, and all these are is longitude and latitude pairs. And we enter here, and it automatically has taken our start and end point from the query string and done the buffer wrap for it. So in summary, we've been introduced to these three Esri library resources: the application base, JavaScript 4x API with ESM modules, and the Esri Design System. We have also seen these resources combined into both a React project and an Angular project, and both of these starter code library repos are available at the GitHub links seen here. We want to thank you for watching this presentation, and if you'd like to provide feedback, please do so by clicking the link below.